Come on, well, I need to pick it up. Okay. All right, on Spooner. Uh-huh. Get cold. What's up? What? Let's see. Okay, this is the reset code. Copy. Come on. Where am I? Where's the... Wait a minute. Right here. Okay, reset password. Use an old one. Oh, man. Okay. Sorry. All right. This visual. Got my visual working. All right. How many people connected? Oh, just two? Let's see. Let me start this. I want to do create a new C++, Windows desktop, Windows. Okay, there we go. Project 1, empty. Okay, we done. All right, let's see something. Plus. All right, how everybody doing? Hope I'm not seeing many people there.
Pretty good. How are you?
All right. Let me get to my Zoom. Okay, here we go. All right, let's see how many people in. Just three people, well, two, Lamada and Spooner. As everybody else said. Anybody got any issues? I never finished grading those assignments, man. I'm still in that conference. I got to do homework tonight myself. Uh, but I'm gonna grade it though. I looked at the calendar. Next week is our pretty much the last week. Finals is the 23rd. Is it the 23rd and 24th or 22nd and 23rd? So that Wednesday and that Thursday. Now this is what I'm gonna do. I'm gonna open up each one of the tests and quizzes with one extra attempt. So what'll happen is if you want to take the test over again, I'll give you an extra attempt, to take it to make a better grade on all the tests and all of the quizzes. All right. So I'll make that available. I'm thinking about just doing it for the final week. The final 2 days, but I might do it from Monday through the final. So you have, those 4 days to take whatever makeup you need to make up. All right. What else? Anybody got any questions about the assignments that was given with the data files or whatever? Anybody with any issues with the data files?
I just want to say that I did mine on online GDP, and it whenever for the program 3, it gave me a separate output file, so I just uploaded that.
That's right.
Okay.
Because it's supposed to. Remember, I told you when you're writing the way we writing the code, the output file will be created. You don't create that. The system will create it and put the data in there, right?
Yeah. Okay.
So and all you do is save that file and send it to me, right?
Cool.
Right. So you did it right. All right. And look, I think your extension either had to be .dat or .txt, right? Because otherwise you wouldn't have been able to upload it.
Yes, sir. Yeah, I just used the text.txt.
All right, and that's cool.
That it called for. Yeah.
Right. That's cool. That's no problem. All right. Any other issues? Any other questions about that? Okay, here we go. That's Mr. Patrick. Question? Somebody had a question?
I just joined, sir.
You did what?
I just joined.
Oh, okay, Mr. Patrick.
Yes, sir.
Okay, all right. Okay, you had got my email about the opening of the test and then quizzes,
yes,
right?
sir. Yeah, I was able to read it just right now.
Yeah, what I'm gonna do, I'm gonna open those up toward I think I'm gonna open up from Monday till the Thursday, because Wednesday and Thursday is our final period. Our final week, our finals exam period. But
Yes,
what I'll do, I'll just open all of the tests and all the quizzes with one extra attempt, so you'll have those 3 attempts, and you're able to take it, and I'll take the best grade of those.
Yep.
All right.
Yes, sir.
What else? Okay, the assignments. You have any issues with the assignments? Questions about the data files or whatever?
Not so far, sir. I haven't finished them yet, but so far not.
Okay, all right. So, like I said, the last chapter we covered the loops, and we covered data files. All right. Let me get back to my screen and do a share screen. All right, so let's share my screen. Okay. All right, so let's go back to I'm not even logged in. All right, let's go here. Okay, so we get into here. All right. So what I did was I opened up a bonus assignment. If you notice, and the bonus come from what you've done already in chapter 5. So and I need to open up this quiz too with the right date. I'll do that. But if you look down here, I opened up this data file bonus assignment. And that bonus assignment, you're gonna be reading data from the file, and you're going to be using a loop to calculate the sum of the numbers that's read from that file and getting a total, right? So you're using some of the same principles you used in the previous program, all right? Now, I got chapter 6 programming assignment number 1 and program 2, all right? Now, in this chapter, we're going to be dealing with functions, all right? And this says, write a program that will allow a user to input length, width, or length and width of a rectangle. Once entered, calculate the area and perimeter of the rectangle. Then output the length, width, and perimeter and area. Make sure you label your outputted variables, okay? But it says use a function to accomplish this. And we're going to go over what functions are, how you break up your program or whatever. Declare your variables as global. And what I'm trying to get you to do, this program, you're going to declare your variables as global variables. When they declared as global, you can use them anywhere in the program without trying to, in a sense, pass the value or redefine the values, etc. So when they global, you just use them anywhere. So it says create a function to input the data. Okay, the same function will calculate the data, calculate the area and the perimeter, and that same function will print the results. Okay, you might not get the gist of it yet, but we're gonna get to it. So that'll be that program. You're gonna have your main function, all right? And you're gonna have your variables declared above the main global, and then you're gonna call that the function that's gonna do these inputs and calculations, and then you're gonna calculate it, print it, and then return back to the main and end. All right, that's the first program. The second program, identical program, but you have different specifications. It says, write a program that will allow a user to input a length and a width of a rectangle. Once entered, calculate the area, perimeter, and the perimeter of the rectangle. I forgot about the area. All right, then output the length, width, the perimeter, and area. All right, make sure you label your outputted variables. Same thing, same exact thing. But this time it says, use a function to accomplish this. This is the same thing, but from this point on, this would make the program different. Declare your variables as local variables. What that means is you're going to declare your variables within the main function. Now, when you declare the variables in the main function, they can only be used where? In the main function. So we're going to go over today as to how to write that program to pass that data to the other function and use that data, all right? So that's what we're gonna do. So if they create a function that, then this is kind of separate. Right, because you're gonna, no, that's still right, that's good. Because you're gonna want you to declare them in the other one. Create a function that will input the data, calculate the area and perimeter, and print the results. Now, I could have told you to input the data from the main and pass the values, but being that I didn't do that, you're gonna have to declare your values as variables as 0, because you can't pass a variable that's undefined with no value. You can't pass something that doesn't have a value, all right? Now, it says use a function to accomplish this, all right? But it says locally declare your variables within the main function, and then the value should be passed to the call function. So I might want to change that because I said it need to, but still you got to pass it. But it'll make more sense if you would type them in the main. We'll look at that toward the end. I might modify it in a way you can understand it a little bit better. We'll see. So those are the 2 programs, all right, for chapter 6. And then we have our exam, all right, our test, okay? Now, yeah, I'll change it to, I'll do that. I'll change the program. I'll go on and change this, I think, so you know, okay. Write the program, perimeter and area. Make sure that you label. Okay. Okay, let's see. Input, delete, and width. And the main function. All right. So input the length and the width from within the main function. All right. So then use the function. I'll just take out, use the function to accomplish this. Let's see. Where would okay. I'm gonna use an input that. Okay. Once entered, then you're gonna once entered, calculate calculate all this and then print it, output it. Cool. That's correct. So I'm gonna copy this. I'm gonna save it too. So I'm gonna copy this. Save this. I'll go to the next one. And then in the next one, all right, so I'll put it in this one, I'll add this information here. So make sure, oh yeah, I just copied all of it. All right, so input the length and width from the main function. But then you're gonna use a function to accomplish this, all right? You're gonna declare the variables locally and then create a function to calculate. So the data will already be in it. All right, so you have the data. Yeah. So to create a function to calculate the area, the perimeter, and area. I got it. I got it. The area and, okay, that's right. And perimeter. Now, so let's get, anybody have any questions? Anybody kind of have some questions at this time? All right. If not, we will go into the chapter. But I'll show you some examples when I get to the Visual Studio. I'll show you examples. So let's go to the notes. All right, let's see what my notes said. I'm at the product. Let me find my notes. Where's notes? Where did I put notes? I put in downloads. Yeah. All right. All right. So the notes. I'll take these out. I need to figure out how to. Here we go. That's it here. All right. Take those two out. Move this over. All right. So what we're going to do, we're going to get to chapter 6. Yeah, hopefully we can get to it. What chapter is this? That's 3. 4. That's 5. 4. 5. All right, so here we are in, and I'm gonna make it a little larger where you can see. I need to move this frame. All right. Control. Oh yeah. All right, so everybody can see this, right? Is that the largest I can make it?
Yes, sir.
All right. All right. So let's look at this. All right. It says we're gonna be dealing with functions, all right, or modular programming. What that means is, you know how you have when you build a home, your home is divided into what? Different rooms, right? Mm-hmm. That's the same way you deal with. You can write programs. You can write programs with several functions. You know, we got the main, right? We could have the main, and then in our header file, we got head, if you use head for the function name. So what you could do in each one of your functions, the idea is to have code that's related or is serving performing a similar task, you know, for a particular reason. So what happens is when you write your code in that fashion, it breaks it down into smaller pieces, And it kind of makes it easier for you to say, okay, I have some issues with my input information. You can go to your input function and look at that and see what's going on. If you have a function that's doing some calculations, you can say, well, I have issues with my calculations. You go into a function where you have calculations. But rather than look at a program that's from start to finish and trying to figure out where and what's going on, your program is broken down in the small segments and making it easier for you to debug, easier for you to execute code multiple times, and all kind of things like that. So it just make it easier for you as a programmer, all right? So it tells us that a program may be broken up into manageable functions. Now, when we use the word functions, we can use the word function, module, subroutine, routine. All those are pretty much are kind of the same. The word kind of evolved over the tenure of programming. You know, they at one time they were calling it subroutines. You know, like a routine, something that we running this routine. We working on this routine. Then they started using modules, you know, and functions and whatnot. So, but they all mean the same, right? So it tells us that a function is a collection of statements that perform a specific task, all right? So if I told you to write a program and break that program down where you have all of the code that's going to input the data in a function, and then have a function where you calculate the data and do all your calculations in that function, and then have a function where you outputting your data. And you'll have all the statements and whatnot related to outputting in that function. And that way your program is broken up into those pieces, and you can actually see it, you know, in a smaller in a smaller way. And then too, your main program would look kind of like abstract, because when you call a function, you might call add data, all right? What add data doing? You don't really know what it's doing until you what? Go to that function and look at the statements. Then your next call might be calculate data. What calculate data is doing? You don't know until you go to that function. Then you might have print data. So your main function done changed from C out CN, C out CN, C out CN, C out CN. Average is equal to whatever, total whatever is equal to whatever, and then see out this and see out that to get, calculate, and print. All right. So that's some of the purpose too. So here it's showing you in figure 6.1. This is how a program would normally be written without any functions. Just from start to finish, a whole lot of statements. Will the program work? Yes, the program will work fine. The only thing is, like I said, when you have to start updating it or adding to it and making it larger to add other functionality, that's when you might have a little bit more complicated time of modifying the program. But then if you look over to this right side, you see main function. Main function got a call statement. Now this statement here is going to be calling function 2. The second one could be calling function 3, and the next one calling function 4. So this is all you would have in the main function. And to execute this second one, you would have the name of the function here, open close parentheses. So they would perform all of this in function 2. And once it gets to the last line or the curly brace, it will return to the very next line in the main, which would be the next call, which is, it says a statement, but it would call whatever function and say function 3. It will perform all of this till it gets to the end, return back, and then the next statement, which is a call, execute that, and it will perform this and return. And if it's finished, it'll end. So you see how functions break your program up, and then you know, well, this is an add function. I know I'm adding some stuff. If this is a print function, I know I'm printing some stuff. If this is a sort routine or sort function, I know this is where I'm doing my sorts. If I have an error with my sort, hey, this is where I would look, you know, to start out. All right. Anybody with any questions so far? All right. We've been writing code what? Similar to this, right? Minus our calling of our header file, our header function. We've been writing code similar to this. All right. Now, defining a call function, all right, we should know how to do that already. And like I say, but we've done it in a header file, but we'll do it in a program. So what it tells us, let's say a function call is a statement that causes a function to execute. A function definition contains all of the statements that will be performed in that function. All right, so that makes up that function. So let's look at an example, which we pretty much kind of already know. But what we'll do, we'll kind of create a program. So I'll just do pound include. All right, IO string. Now, at this time, I'm gonna show you, I'm gonna declare the variables global. All right, so int main, all right, open. Now, say if we had a function like, say, what we was doing one time, we was reading in some numbers, all right? Say we read in gas mileage, I'll just say int gas. Well, we did gas, we did, what else, tires, like when we were doing the prices, all right? I would say tires and what else? Just something else. I'll just say cost. And like I said, we just gonna use int. All right. So now I have this. So what happens is I can do cout, if I could type. See out enter gas cost, right? Then what? CN, all right, cost. Now you know gas. Now, like I said, we're not doing nothing with string, but you know string, depending on how you want to read it in, what you're reading in, you're gonna use the get line, whatever, or whatnot. All right. Now cout all right. Like I say, we just use an int, but all right. So now, this is what we're doing. We're retrieving that data, right? We declared our variables up here. I can make this a little larger. All right. We declared our variables up here, gas, tires, cost. Here, we reading in gas, we reading in a value for gas, reading in a value for tires, reading in a value for cost. Now, what I can do, I haven't called it. Now, I could create a function, all right? I could say void, and I'll tell you the difference between void, the other, whatnot in a little while. So if we are not sending any information back to the main function, we can make our function void. So I'll say void, and I could say calculate, or calc, whatever I want to call it. Whatever, as long as it's a valid C++ name, all right? And my finger hitting this button. All right, I'll call it calculate. Now, the thing is, I have to kind of define, I'm gonna have to define it just like I define my function in my what? Header file. Function header, beginning of the body with the open curly brace, closing of the body with the closed curly brace. Anything within here is gonna be executed within when I call that function. So in this function, what I can do if I wanted to get a total cost. Now I could have put total up here, right, and use it down here. But now I could introduce total here, being that I may want to print it here. I could say int total, right? I fucking type, right? Then I could say what? I could have just said int total equal, right? Total is equal gas plus, I could type, tires plus cost, right? So, and like I told you, I could have done it this way, being that I'm doing it, well, but I would do it, well, either way, I'd have to control it. I'm not thinking about doing a loop. But this is good. Doing it this way is okay. Either way would be okay. Now, so I've calculated the cost. Now I can output my data. I could output cout gas and I could continue on, but I could stop it and I'll do cout I could have made it what, one cout, right? Now, and then I could, I need to do inline. That's what I need to do here. All right, so I have this. And so now my total, if I want to output my total, cout all right. Okay. So now, so what? I have my variables declared as what? Global. All right. They're outside of they outside of any function, the main function or even my calculate function. So I could use any one of these variables anywhere I want. Now, total, look at total. Total is what type variable? Global or local? Hi, class? Total is global or local?
Local
To what?
to the main.
No. Where's being introduced? Where did I declare that? Look here. In what function?
In the void function.
No, not void, but the what? Calculate. Void is just a data, like a data type.
Okay.
So calculate is the name of the function. See here? Int, that's the data type, but main is this function. Void, that says no data type, but calculate is the function. So total can only be used in what function? The calculate function, or is only known in the calculate function. You got me?
Yes,
If
sir.
I tried to come back up here and output the total, it would say a variable not defined. The scope of total is only the what? The calculate function. Remember we talked about scope before?
Yes, sir.
Right. So it only, the compiler only knows what total is while it's in the calculate function. And that's what I was telling you, the difference between global. See, this is global. Now, your program, you're gonna write it where you're gonna have your variables global, meaning all of them up here. And then you're gonna write the program, it's gonna be fairly simple. But then when you just take this one statement and put it inside the main, and then try to do all this, you're gonna get all kind of errors. But I'll show you that. But let's run this program. Because if we look at it, we have these global variables, we have our main getting the values for these variables, and then we have another function printing out those variables, right? So those
Right.
variables can be used anywhere because they're global, except for total. Total can only be used in calculate. So let's run this. All right, so I'll do the bill. Okay, and I'll do the run. All right, and let's see what we get. All right, see it say enter gas cost. I'll say put $10. Tire cost, I'll say 40, so that's 50. Enter vehicle cost, I'll say 100, so that's 150. Oh, I didn't even, did I output total? Did I output total? I thought I did. Yep. What happened? What happened to total? It got the vehicle cost. Why didn't it output total? Something is wrong. See out this in line. See out /n/n/t total, then total in 2 lines. Let me run it again, see what happens. I don't know what's going on. Okay, 10, 40, 100. What is happening? /n/n BNDL. What's going on? Let me run this. What's happening? I don't know what's happening here, Claire. Because I'm saying I have my C outs. What's happening? It's like after this line, it's stopping. Do I have anything under that? No. I'm reading in the cost. Int total. Total is equal to gas. Total is not a reserved word. Cell total. Man, I don't know what's happening.
It wouldn't work if you put that C out total at the bottom of the inner vehicle cost.
But I got where we're at.
Like that C out less than total right there that you're on. If you put that up there before the void, and then just left that like C out less than, you know.
Talking about up here?
Yeah.
It's outside of a function.
Oh, okay.
Yeah, you know, let me, man, I don't know what's happening. Let me do something. Because I'm saying that's the code. Let me see what online GDB say. Because I don't know what's happening. Paste this. Okay, let's run this. Okay, 10, 40, 100. It's still. I don't know what's happening. It's doing this last one here, but anything after that is not. NL, total. Man, it got me baffled. Let me do this.
Yeah, that's weird.
Yeah, something's going on. Let me do this. Cut this, and I'm gonna paste this here. All right, and total. Okay, let me run this. Okay, 10. It's nothing. All right, Whoa. Oh, class. And that's my fault. That's my fault. And hopefully it's a good lesson. It is doing what it is programmed to do. This is what's going on. Because really, it's not even outputting that. That's just my what? My input statements, correct?
Correct.
What must I do for it to execute these statements? Remember the head file in the head function in your header file? What we had to do in order for it to execute?
Let me see.
Bam, we gotta call it.
Oh, okay.
We never called this function down here. All right.
I see it. Yeah.
So being that we never called it, that means we don't want to execute it. You understand? So
Yes.
that was my problem. So what I'm gonna do, I'm gonna delete this one, which was I had that total. So now, so int that, we know we calculating the total, then we print out the gas, the price, or whatever. Because what happens is this program will input the gas, input the time, input the cost, and then it was gonna stop. You understand? But we need to get it to execute those statements in the what? Calculate function. So we gotta call that function. And so we call it, and now it's gonna execute. So let's run it now. So it should run now. And that was an error on my part. Oh, now I got errors. I'll say no. So let's see what my errors is. I gotta move this screen here. Get all that messed up. It said what? Calculate undefined. I spell CALCULATE. Oh, man. Now we got to declare it just like we declare our variables. Your prototype. So the prototype would be void calculate. So it's a three-step process for a function in your program. This void calculate is the prototype saying this is how it's going to be used when it's defined. There's no returning variables or values, and it's void, all right? If it was int, this would have to be int calculate, okay? So this is actually doing like this. Just like I'm saying int gas, this is like saying I'm declaring my calculate function. Now, I could have some programmers do this. They take the function and define it above the main. If you do that, that's just like defining it or declaring it, okay? But when you do that, you're gonna have to make sure your functions are in the logical order, or you can run into some issues, all right? A variable not defined before it's used. But look, so let's run it. It should run this time. So now, and we'll go back over those three things. So I'll put 10, I'll put 40, and I'll put 100. Now, when I hit enter, it's gonna call the calc function, which execute what? Gas and give a price, times and give the price, cost and give the price, and then total, it give us the total amount. Everybody see that?
Yes, sir.
Got it? All right, so the three things that we had to do, okay? I didn't do it first, but what? We had to declare that variable, that function, all right? Give it the prototype, whatever the prototype, saying, hey, we want to use this variable function called calc. Then here is why we call the function called calc. But in order to call a function called calc, I have to have it what? Defined. And outside a function by itself with a function header, and then the body is the definition of the function. So those three things you got to remember. Now, if I wanted to even add another function, I have to do the same thing. Like if I had, say, a footer, I could say void footer, okay? Say I had a footer announcement or something to write in my program, all right? But then what? I'll call my calculate, and I'll call my footer. But now what? I need to define what footer is going to do. I could put it anywhere in, long as it's not in the body of a function, okay? I could put it prior to this, because what? This in my main function, this start my calc function. Or I could put it at the end, long as it's not within it. So I could say void footer, if I could type footer, all right? And then I could output something like whatever. I could say cout. You know, whatever I want to put. All right. So what happened is, I need no semicolon. All right. So what happened is, it's gonna execute this. It's gonna call calculate, which is gonna output the data, and then once it completes that last cout statement here, it's gonna say, okay, I'm at the end. Return back to the main function. The next statement after calculate is footer. It's gonna call footer and execute footer, and then the last one, and then it's gonna return to the main. And like I say, I didn't have it, but you could put return 0. All right, which means the program gonna end. All right, so let's run it. All right, and I'll just put the same value. All right, hit enter. So see what happens? It printed out what? This come from what function? Well, all of this. From what function? What function was this? Where we printed out the name, the values and stuff. What's the name of that?
Was that the calculate?
Calculate. Now, what function did the input of the values?
That was a main.
Right. Now, what function printed out program works fine?
The footer.
Correct. So you see, this program have 3 separate functions, right? So the program was broken up. Now we can make all this into one file, one program too, right? Everything in the main, and it'll work. Correct. We just have to put it in the logical order. Now, let me show you the beauty of this. Now, I don't have it logically written where we reading in and doing different calculations, but watch this. Say I wanted to perform the calculate function twice. I just simply do that. And what? It's gonna call it what? 2 times, all right? So see how I didn't have to go and write code again, right? So now when I put this, right? So you see it did it once, it did it twice. Now you say, well, Mr. Vester, that's redundant because it's the same data. That is true. But what if you're reading data from a data file and what? That data file taking data and bringing into that function. Each time that data changes, you don't have to try to what? Rewrite the code over and over and over and over again, right? You just simply what? Grab the data and call what? Call that function, right? Everybody get that?
Yes, sir.
Right. You write that data file, grab the data from that, go get to the function. The function gonna calculate it, print it, read the next file, call calculate the data and print it, and then read the next one until you get to what? End of file. So see that's what you're trying to get to. Trying to understand how you can use those functions over and over and over again. So watch. What I can do, I could kind of make it somewhat realistic. Let's do this. I'll do something like this. Well, I'll show you this part first. I could say for int x equals 0, x less than 3, x plus plus, right? So now what's going to happen, class? How many times will it execute perform calculate?
3.
How many times?
3.
3 times. So you see how I could put it in a loop and it's going to automatically execute rather than me having to what? Try to rewrite this over and over and over again, right? So that's one of the beauties of having functions. You could just call that function and it's gonna go and do what you want it to do. Ain't got to recreate it. You make a change and the change is only needed to be made one time. So see here, one, that's the one above it. Let's see where my cursor at. Yeah, that's the one above it, that one, and the other one. Right, and then the program works. All right, so in an example of this would be, all right, I'll take this out, all right? So I'm gonna take this out. I'll take, no, yeah, I need to take that out. Take that out. Take this out. So we calling calc. We calling calc. All right, we're gonna call calc. So we'll do this. We'll do something like this. Pound include F string. All right, pound include F string. And then what? We could do something like IF string and let's say in data. Okay, right? IF, yeah, that should be right. Yep. And then we can do, what's wrong with my IF string? My IF string, in data, dot open. I might have to put that inside. And data.txt. So what's wrong with my IF? Oh no. Why is it? Oh, what did I take out? Why am I IF? Why am I IF? Oh, no, that's right. IF string. I'll include F string. STREAM. IF string. Using namespace. I must have deleted it. All right, so now we got it. So I'll take this and cut this, and I'll put this in here. All right, so now, we read in data. We read data from a data file called in data. So what I'll do, right click, add, new, utility, text file, data.txt. All right, so I'll say we're reading, I'll say 10, 40, 100, 20, 50, 200, 30, 60, I'm just 40, 70, 400, 50, 80. All right, so we have this data in here, all right? So, let's see, yeah. We have this data. Now, go back to here, and now, we don't need this. I'll just comment it out. Comment that. Comment. And there's a different way we can do it, but I'm just doing it that way because we could do the CN gas stream, tire stream cost, right? But I'm not gonna try to rewrite it. I'll leave it like this. So now I need to do something like while not in data, in data dot EOF. Right? So now, what it's going to do is going to try to what? Read till what? The end of the file, right? Everybody understand that?
Mm-hmm.
Now, I might need to take them off, but I want to leave that. Now, it's very important for me to know where my loop begin and end. Now, look at this. I have my variables declared. I have my data file as data.txt. So that should be okay. Now, look at this. While not in the file, what I want to do, I want to get gas, I want to get times, I want to get cost. So that's 3 different what? Numeric values I'm getting, right? So if we look at here, 1, 2, 3. If I took this 100 off here, the first read would read 10, 40, and 20. Everybody understand that? And then the last one, you would get an error because it'll be trying to read a number and it'll read in, or it won't have a value to read. So you'll get an error on the last record. But all the rest of the records would work. Everybody understand that? So you have to make sure, like when you got that loop and you read from that file, you read in like what you're supposed to read in. Now, I could have what? 3, 6, 9, 12, 15. I could have them all on one line, separated by a space. But then I have to kind of group them in threes to know which record is which. Looking at it this way, 3, 3, 3, 3, 3. I should know every time it read, the first read gonna read this, this, and this. Next read gonna read this, this, and this. Next read gonna read this, this, and this. So it doesn't matter how you write your data file, but you have to know how it's written so you can read correctly from it. Okay, so that's one of the keys, to know how to read from it. So now, so let's look at back at our program. So now in this program, so we're gonna read gas, times, cost, and then we're gonna call calculate. Calculate gonna say, okay, total, all right, total is equal to gas times gas plus times plus cost, and then is what? Calculated. Now notice we got an int in here, but each time it calls that function, it's introducing total all over again. You understand? Because once I kick out of this, I lose it, but then when I come back, int total, so it's not that it's going to be all, you're going to get an error here, because when you introduce it or you're entering, each time you enter it, it's like you're introducing it for a new time, at the first time. But now, it's going to calculate, but what? I don't want to write footer every time I read and write out a record, correct? I only want to write out the footer text when what? I'm finished with the entire process. So I would have that outside of the while loop. So I'm going to read, calculate, and print. Go back, read, calculate, and print. Go back, read, calculate, and print. So everybody understand what's happening. So you got to know how and where your loop should begin. So let's run this and see what happens. I got an infinite loop or something. Oh, you know what I did, class? Now that comes from the chapter. I cannot do a CN. I must do a what to read the data from the data file? I must use the what? I must use that object, data in data, right?
Right.
Right. So it was looking for a CN, but what? No, it should be what? Data in, right?
Right.
All right. So it was waiting for me to type in, not data in data. Right, in data. And like I say, for good housekeeping, normally what you would do, you'll do a close, well, let me see if I could get to it. In data dot close to release the file. All right, so let's run it now, see what happens. All right. So you see, let's look at the first one. The first one was, here we go. All right. Yeah, the first one was 10, 40, 100. That's 150. The second one was 20, 50, 200. That's 270. So see how it did each one of the records? It did each one of those records. Now I did the last one twice. That comes from this, that empty file. Now it should run, okay. So when I do debug and run it, see, and that's it. All right. So that's when you are calling a function. Remember, calling a function, you have to do your prototype. All right. Then you have to do a function call. Then you have to do the definition. All right. Any questions so far? Questions? So we went through this. Now I say void. When you use void, that means you're not sending anything back to the main function. Now I'll show you that right quick. In this program, if I try to print out the total in the main function, I will get an error, okay? I will get an error. Now, what I can do is in here, so I got a total, right? What I'm gonna do, I'm gonna get a cumulative total, all right? I'll do something like this. Or can I do it here? No, I'd have to do it another way because I'm calling. So what I need to do, if I wanted to take total and bring it back to this particular area. Now, what I can do, I can create a variable called final total, all right? Now, final total is declared, and I need to just set it equal to 0 because I'm gonna use it on both sides of the equal sign, all right? So now, in here, final total, all right? I need to get final total back, the total that's calculated back to the main function. When I do that, I'm gonna have to change my prototype to int because I'm gonna return an int value. So here my prototype change. So see, I got that error. I got to change that to int. So you see now, rather than void, I use int. But now, when I got a function and I got int, just like in the main, I have to return something because that's saying I'm returning an int value. So I need to tell it what value I'm returning. So I'll say return. We normally just return 0 to say it's the end of the program, but I want to return that total that's calculated. So I'll do return total. Okay? I'll do a return total. So now I could come back in the program and say the main program and at this calc, and I can say int x is equal to calculate. Well, I'll say tot is equal to calculate. All right. Now, so what's happening? TOT is being returned every time I execute calculate, correct?
Correct.
Now, so I could say final total is equal to, or I could do plus equal total. So what I'm doing at this point, I think I do final total. Yeah. So what I'm doing at this point, I'm calling calculate, but I'm gonna return total into what variable? Into tot, right? Everybody see that? The return value gonna be returned into this variable here, which is an integer. Everybody see that? Then that total value that's returned gonna be added to final total. All right? And then outside of here, I could output final total. Why? See how? All right. So now, so what I'm gonna do, let me change the output look of this right here. So we're gonna see out this. I'm gonna take them inlines off of here, so it'll be all on one line, but it's separated by that tab. All right, and then the total. Okay, so all I did was made a tab between each one rather than going down the line, so you could see them all going across. And you know we could use a set W and they all could be straight aligned, all right? But we didn't do that. All right, so now let's run this. So look what happens. Let's look at this program. The first one was what? 10, 40, 100. What's the total? 150. 150 was returned back to what? To the main function in a variable called what? What was that variable in the main function?
Total.
Yeah, but which one it was returned back into? Total, remember?
Total.
Remember? Yeah, calc, whatever this calc function returning, we saying is equal to TOT. So what we did, we said what? Whatever that total value the first time it executes, we want to store it into a fin total. Second time it's come through, we want to add fin total is equal to fin total plus total. Next time through. So if you look at this program, 150 was added to the final total. 270 was added to the final total. 390 was added to the final total. 510 was added to the final total. And 630 was added to the final total, giving us what? 1950. You got me?
Yes, sir.
So see how I was able to take the value and return the value back, because I could not use what? I could not use a total up here because total was what? Local only to what? Only to that function. So I had to return total, but when I returned total, I had to return it and make it equal to, make that function, whatever it's returning, equal to total equal to that function return. All right? Now, I can return a float, I can return a char, I can return a string, just like I can return an int. Everybody understand that? But I only can return that one value, all right? I can only return one value, all right? So now, any questions? Like I say, I kind of went a little ahead to show you how you do a return of a value, all right? But that's how you return a value from a function, all right, when you're using it. Void, you cannot return anything. If I'd had void in front of the calc function, that's saying I'm not returning any value. If I have float, that means I'm returning a float. If I have int, that's saying I'm returning an int, all right? So if you got a data type other than void for a function in front of a function name, you are returning a value, okay? Otherwise, you're not returning. Because look here, they don't need to return a value for this because they just output some data, right? Void, display message, and then what? See out that, they finish. They don't need to return anything, right? But now look, remember what I told you about a function? Look at this program. This is the main function, right? Everybody see that? Now look what they did up here though. They didn't create a prototype for the function display message. They just defined it where? Before the main function. Everybody see that? So when they define it before the main function, you don't have to set a prototype. But you still need to call it to execute it though. See here, this is why they say see out hello from main. But then what? go to display message and execute it. It says what? Hello from the function display message, new line. Then, oh, I'm at the end, go back to the next executable line. See out? Oh, back in function main again. And then what? Return 0 back to here. Oh, I'm finished. Right? Everybody see, that's how functions work. All right? But like I say, you could do the prototype. It doesn't hurt. And I could even show you in the program we did. All right? I can take this program or this function here, all right? Or both of them. I could take both of these functions, cut them, and now what I want to do, I want to put them above, put them here, because I don't need these prototypes. I just need to paste this here. So now I have the definition of the calc function and the definition of the footer. And if I execute the program, it's going to run just the same. So when I run it, when I do debug and run it, get the exact same. What does it say? Build error. Let me see what doesn't happen here. See, that's the message. That's the error I was trying to tell you about. Remember, I said I'm defining this function. I'm not doing a prototype, but I have it introduced, right? So the computer looking at this saying, okay, calc function, total is cool. Gas, I haven't been introduced to gas yet. You understand what I'm saying? So that's how you can get errors, all right? So I'm gonna have to take this statement and cut it, right? And put it before I even mention gas and whatnot. You got me? So now, I forgot. What happened to the semicolon? Oh, no, I put it inside. Let me undo this. I put it inside. It go outside the function. Can't go in the function. And paste. All right, right. So now, so everybody kind of see what I was talking about. I introduced the calc function, and I also introduced the variable gas, time, and cost, but the computer did not know what they were at that time. You understand? So that's how you can kind of get caught up if you just define them up here. But if you define them at the bottom, then like I say, you know you have your variables declared at the top and your program should work. All right. So if I run this, it should run now. All right. See here? And it runs. But that simple what? That simple movement of those variables. Hey, I got to declare gas. If I'm using it in that function, it has to know what it is before it's being used. All right? But it done what? The exact same thing. So I could create the prototype and define the function at the bottom of the program, or I can define the program at the top and not use a prototype. Okay, but like I said, it get a little tricky because you got to have it in the proper order of when you're introducing your variable. All right? Okay. Now, so again, all they're doing is showing you what's happening. All right? It executes this statement. When it hit this one, it goes to the void display message and it executes this. Once it gets to the end, it returns back. It couts this and then returns 0, it stops. All right? Simple as that. All right? So that's all the program is doing. All right? And you got to understand the logic of it, because now the reason why you have it 5 times here is because what? It's what? In a for loop. So what happens? It outputs this, and just like I had done with the data file, I said while not in the file. This one says what? For count is equal to 0 to 5, less than 5. So what? It call and display message 5 times. Then at the last time when it kicks out the for loop, then it output back to the function. Now, let me ask you this question. The first time it execute display message, it goes to this function, right? Does it stay in here and execute it 5 times, or does it come back here to the main? Huh? What you think it does? Do you think it stays here and execute 5 times and then come back? Or what?
Does stay in the main?
It doesn't. What happens is it'll say, okay, I gotta go to display message. It'll go to display message. Well, first of all, let's stop. Okay, for count is 0. So count is 0. Count 0 is less than 5. Oh, display message. Oh, go to display message. I execute display message, one statement, see out. Okay, I'm at the end. It has to return back. When it returns
Oh,
back,
I see.
right.
Yep, so it
I'm
does
at the
that.
end. 4, it goes to 1. 1 less than 5. Okay, call display message. It goes back up. So it's going to repeat that 5 times, but it got to keep going back and forth. You understand? That's how it works until the count is satisfied, and then it exits the program. All right. So that's how it works. Okay. And like I said, when you're writing code, menus and whatever, you can do that. Like if you had a password menu, all right, you can have it to where that menu displays 5 different times, or not even the menu where I say, okay, please enter your password and your login. It goes and checks it. All right, it goes and checks it. Okay, 1 error. All right, 1. Okay, then it goes back, display it again. You might have an error count. Error count is 1. Type in the name and ID. Go check it out. Oh, error count. Error count is 2. If your error count is 3, okay, they type it in again. Okay. Oh, error count. All right. Kick out and come back. Go to a screen. Your login is locked due to excessive login attempt. So you understand what I'm saying? It'll perform it until, and then they kick you out. Okay, you can actually go to somewhere else. All right. So it'll keep performing that same thing over and over for how many times you want it to perform. And then, like I say, you can go on to another part of the program. All right. So looking at this program, all right, this program have a function called first, second, and then main. Now, remember I told you what? You can define those functions at the beginning of the program. That's not a problem, as long as you put them in the order in which the proper order in which you introduce your variable. All right. So you have first and second. Now, which one you call first, and when I mean call, which one you call to execute first, it doesn't matter. Which one you call to execute X number of times, it doesn't matter. You can execute them as many times as you want. All right. So if we look at this main function said, okay, see out, I am starting a function in the function main. And then what it says, oh, go to the first function, go to here and say, oh, I am inside first a function first. Oh, I'm at the end, return back, execute the very next statement. Second function, oh, call second function, it goes to second function, output that statement, then what? Return back, and then what? See out, back in main function, return 0, I'm finished. Right? But now, you could reverse these. If you reverse them and have second and then first, it would only execute what? Second first and then execute first. So and there's no order to call in a function. You write your functions, you could call them in any order you want. But like I said too, though, when you define them at the top of the program, you have to have that order in a logical order, or you can get errors like we did just now. All right? So they're just telling you got 2 functions, calls, first and second. And it calls the first one and returns back, and it calls the second one and return back. And if you look at this, they're just telling you what happened. That's why every program has a main function. The main function is the first function to be executed. Class, I'm sharing my screen, right?
Yes, sir.
Okay. The main,
Yes, sir. Yeah.
All right. The main function is the first function to be executed. So any other function that's called has to be called first from the main. Now, let me ask you this question. I have function main, first, and second. Can I call function main first and from first call second? from the main, I could call first. And can from first I call second?
No.
Yes, you can.
Yes.
Now, let me show you. But, well, I'm going to show you. I'm going to show you first, and then I'll tell you why. Let me undo this. Well, I could leave it like it is. All right? So, look, we have what? Calculate, define. We have footer, define. But then we have our main function, and then we have what? Calculate, right? And then we have a footer. We're calling our footer down here, correct? Now, check this out. I could take this out. Let me delete. I could delete this. Now, the logic ain't gonna be right in a sense, but let's do it anyway. So I'm gonna do a cut here. I'm gonna go inside of my if I could get to it, inside of my calc function, and I'm gonna call footer. So what's gonna happen is it's gonna execute main. It's gonna read in the gas, the tires, the cost. Okay. Then it's gonna say, oh, calculate whatever. All right. So I'm calling the calc function. It's gonna go back to the calc function, and it's gonna say, okay, int total, calculate what the total is, output gas, output tires, output cost, output total. Once I output the total, output my what? Footer. Program works. So what's going to happen each time I output a person's gas, tires, and cost? It's going to output program works fine. You understand what I'm saying? Because what? I said output gas, output tires, output cost, output total, but then call footer. So it's going to what? Go to footer, print this, it's going to return total, and continue on with the program and read another record until it gets to the end, and then it's going to stop. All right? So let's run this, and let's see what happens. Oh, I got an error. Let's see. Footer not defined. So footer, and now what I told you about, remember I told you about the order in which the order in which you display your define your functions. Here, footer is being introduced, right, in the program, correct?
Correct.
But it's not defined until afterwards. It's like trying to say x is equal to 5 without declaring x to be integer first. So I need to take this. So see how it's like I say, I like to do all mine at the end, but like I say, you don't have to, all right? So what I need to do here, if I'm gonna use footer in this function, I need to define it before it's being used. And now it should work. So see how I had to modify this program a little bit just in order so not to get an error. Even though the code is correct, the logic in which it's introducing those functions and variables might not be logical, all right? So now once I run it, you see what I'm saying? And after each one, what? Look, what's it? First, program works fine. Output, read, calculate, print, output is fine. Read, calculate, print, output is fine. So I can call a function from another function, and I could go deeper. From the main, I could call function A. From function A, I could call function B. From function B, I could call function C. From function C, I could call function D. You understand what I'm saying? So you can go deep in levels. This is the key about functions, though. If I'm in function, in the main function, and from the main function, I call function A. From function A, I call function B. And from function B, I call function D. When I complete the execution of function D, where do I return? To the main, to A, to B, or to C?
You return to the main?
No, you always return to the calling function, the function that called it. All right. So if I'm in D and I complete D, I have to return back to what? I call from main, I call A, B, C, and D, then D. So I'm in D. When I complete D, I need to return back where?
To A.
Huh? What function called D? Think. Main call A call B call C call D.
So it'd be C.
Return back to C. Correct. Now, I execute everything and get to the end of C. Why do I return?
To B.
To B. I complete everything in B. I'm at the end, I return. Why do I return?
A.
To A. Complete everything in A. Why do I return?
To the main.
Back to the main. So you see how that works?
Yes, sir.
It always, that's how it always works. You have to return to the calling function. Have to. And like I said, you can have several levels, but you always return back to that calling function. All right? Logically, you got to do that. All right? You got to return back to that calling function. All right? So, now, and like I said, a lot of these, what they do, it's showing you what? It say what? Function, say definition of a function, deep, function deep. This function displays a message. But let's see something. Let's look at it. You got the main, you got deep, and then you got deeper, which is what we just talked about. Because look, you're in the main. Main calls what? Look here. Main calls deep, right? So you go here, you go to deep. Okay, now the deep function says what? See out, I am inside the function deep. Oh, but deep call what? Deep is calling what?
Deeper.
All right, so now we have to go into deeper, and deeper does what? Execute this see out statement. Oh, I'm at the end. Where do I return? To the main or to deep? What called deeper?
You return back to the deep.
Correct. Return back to deep. But then look, I'm not finished with deep. I got to go to the next executable line. Okay, so I have to output this. Oh, now I'm at the end. So now I return back to the main, and I'm not finished with the main. I have to finish these statements, and then I'm finished. You got me? That's the logical flow of what? Function. You always have to return back to the calling function. Always. All right? That's just how it works. All right? And like I say, this is some example. Well, this is a homework assignment somewhat. You got the main, int main. Okay, if this is calling function one, then it calls function two. All right? And this say else call function two, call function one. So depending on what's inputted, it could execute what? Function one first, then function two, or it might call function two, then function one. All right, depending on what if the number is less than 10 or greater than 10. All right, but that's a homework assignment. But look, they both defined at the top as to what's going to be printed. All right, whether they're going to print Ava was I or I was elbow. All right, either way, but one of them is going to print one before the other, depending on the input. All right, function prototypes. Now, like I say, that's normally how I write them, using a prototype. Because when you write the function with function prototypes, you're not worrying about making sure, or if you modify your code, making sure that, this function has to be before this one because I have to have this variable declared before this one. Hey, you do your function prototypes and all your definitions at the bottom, so the prototype define them all and it's done. But like I say, programmer style. You might like to do it at the very beginning, and nothing wrong with it. Either way you do it, no problem. A function prototype, normally you'll give the data type or void. Now remember what we said about void. Void means you're not returning a value back to the calling function. If I had int, char, float, bool, string, then I'm returning that data type back to the calling function. All right. So that's the only reason you would use a data type, if you're returning a value back to that calling function, right? But void says, okay, I'm just creating a function. I'm going to execute some statements and then return back. I'm not returning any values, right? So that's all that is. So what they're saying is, if I'm going to use a function called first and second, I have to set up the prototype. Void first, void second. Okay, now they're defined here, but they're not defined. They're declared here in the prototype. They're called here. When you call a function, notice you don't have int or void or whatever. You just have the name of the function, open, close, curly brace, parentheses, semicolon. Now, in a little while, we're going to get to what goes into these parentheses, all right? And sometimes it can get a little confusing, but once you get it, you're cool. Because in those parentheses, that's when you can tell it, I want to pass an integer, and an integer value. So what? If my scope, if I have 3 variables in the scope of the main with some values, and I want to use those values in that call function, I have to pass them as arguments in these parentheses, all right? And we'll go over that a little later. But looking at this is your prototype. This is your call. Your call, no void, int, or whatever, just this. Now, remember, if we were returning a value, we would use the int or float or whatever, and we could say, like, if we was returning a char value, we could say char letter equals first, and when first returned that letter back to the main, it will be stored into that variable called letter, and then we could use letter to do whatever we need to do with it, right? Or if it was a value. Now, okay, so it calls first and second, but then look, outside the main, I define my first function header, body, open curly brace, close curly brace. Function header, second, all right? Then open curly brace, close curly brace for the body, all right? So that's if you use the prototype. But we could have done the same thing by just taking these 2 functions and putting them up here where you have the prototype, and it would work just the same, all right? It will work just the same. Now, here we go, passing values. Sending data into a function. Now, in doing that, notice this function here. This says void. So the void says what? We're going to go to display value, but we're not returning anything back to the calling function. But when we go to display value, we're going to pass an integer value, all right, into num, all right? So this is the definition. So whatever you passing, an integer value will be placed into num. And then now num is being declared in display value, and now num is known in the scope of display value. So let's look at that. Let's take our program. So let's look at this program. So we have, and I could leave it like this, but I'd rather, we could leave it like this. I like them at the end though, but I like them at the bottom. But it doesn't make a difference, all right? But what I'll do, I'll just put them at the bottom, all right? I'm gonna cut this and put this down here. All right. So I'll paste this down here, and then I'll have to add my what? Prototypes. So I have to say what? Int calculate, and I'm gonna put it just like it was before we started. And then what? Void. What did I call it? Footer. All right. So this is our prototype. This is our main function, and this is our footer and our calc function. Now, right now, gas, tires, cost, and fin total is global. I can use those variables anywhere in my program. I won't get an error, whatever. I could have a million lines of code. I could use them in any function anywhere in my program. If I simply do this, take this, cut this out, and I paste this inside of here, all of a sudden, now, this part is correct because what? The scope of gas is in what? And tire and cost and fin total is in the main, right? That's no problem. But if I scroll down to calculate, what happens? It does not know what gas is. It does not know what tires is, and it does not know what cost is. And even here, you would get errors on this because what? The scope of gas, tires, and cost is in what? The main function. Now, what we need to do is find a way to take the values that we read in the main function. If I could scroll up. Come on. I need to take these values, once I read from the input file, the gas price or the gas amount, tire amount, cost, and send it. When I call calc, I need to send it to the calc function. Okay? Now, the way you do that, and look, how many variables I want to send? 1, 2, 3, correct?
Right.
Now, what are their data types? What are the data types of those variables? What's the data type of gas, tires, and cost? What'd that say here?
It's the integer.
All right, so it's int. So what I need to do in my prototype, I want to pass those three values. So I need to say, okay, I want to pass an int, and an int. Everybody got that? I'm passing three integer values when I call my function over to the calc function. Because each time I read, I'm going to pass those three, calculate print. Go back to the main, read three more, calculate print. Everybody understand that?
Yes,
So I need to tell it int. Now I don't need to give a variable name here because this is just the prototype. This is just the prototype. Tell me how that calculate function is going to be used. I'm going to pass three values and I'm going to return one. The value I'm returning, remember, was what? Tote. You know, well, really total, but I'm returning it back in the tote. Whatever calc returns is going to equal or be sent into tote. All right. Now, that's one thing I need to do. I need to tell it the data types of each variable I'm sending. Now, I could have float, char, int. I could have string, int, bool. I could have string, char, right? Everybody understand that? But as long as I have the data type in its proper order, it's kind of like reading data. Remember how we were talking about reading data? If I read three different data values, and if I have int, float, and I did a 7.7, then 5, and then 3, it's going to take 7 and put in that int, and then the float is going to put 0.7. Same thing here. If you mess up with the data types, your data can come out incorrect. Okay? So if I'm passing int, I know that the first variable is an int, the second one is an int, and the third one is an int. If I'm passing string, float, int, the first variable that I pass should be a string, the next variable I pass should be a float, and the next one I pass should be an int in the list. So now, I give my prototype. So now in my call function in here, this is a function where the variables are known. So in calc, I want to pass what? Gas, tires, and what? Cost, right?
Mhm.
Int, int, int. Everybody see that? Now, this is where the confusion could come into play. The first variable is gas. So when I fix my function definition, I don't care if I call it cost. The value of gas going in the cost. Everybody got me? So you as a programmer got to make sure your data is in line, in a sense, in the list of how it should be received. Everybody got what I'm saying?
Yes, sir.
All right, because if I have gas listed here, it's gonna say, okay, when I call calc, whatever the value of gas, I'm gonna pass it in the first variable in the list in the calc definition. Whatever the value of tires is, I'm gonna put it in that second variable in the list in calc, and then I'm gonna pass the value of cost in the third variable in the list. So you got to make sure that you have your list correct. If you have more than you have in your arguments, say like if I have my prototype, I have 4 ints, int, and in here I have 3, I'm gonna get a linkage error. All right. So you as the programmer have to make sure when you either updating or when you coding, all this stuff is matched, all this stuff is aligned. Because those type errors, you got to really find them. It'll just tell you, okay, you got a link error between whatever. What that means is I'm trying to pass 4 values, all right, and you telling me you sending 3, and some kind of way it can't link up, so it gives you a link error. So you have to know to go back and check those your argument list. Now, so like I say, first of all, we did what? Told it what data types, int. Then in our function call from our main, we're passing gas, whatever the value of gas is, tires, whatever the value of tires is, and cost, whatever the value of cost is. Now, in our calculate function, this is a whole new scope. Everybody understand that? Now, why would I say that? I'm saying that because you can use the same variables that you pass from the call function, no problem. So I could do what? Int gas. Oh, if I could type. So I'm introducing a variable called what? Gas in calculate. It is not the same variable in the main because the scope is different. Everybody got that?
Yes, sir.
The scope is different. All right. And then I'll say tires, comma, and then cost. Now, I got to do int, my fault. Because I got to do the data type for each one. Because what? They could be a different one. So I gotta list the data type for each. So now int gas. Okay. So for the first record, 10 will be passed in the gas here. Int tires. 40 for the first read. 40 will be passed in the tires. And then int cost. 100 will be passed into this. And then what? Total is being introduced into this function, int total. So total is equal to gas plus tires plus cost. It knows what they are, calculate it, print it, and then return. Now I could take footer out here and put it back like it was. Okay, I'll do that. I'll cut that. All right. And now this program gonna run the same. All right. But if you look at it, this is basically what you're gonna be doing in your program. Remember the first time we wrote this program, we had what? These variables here as global variables. Now we made them local. We read the data, but then what? We had to pass the data to the what? To the function that did all the work, like the calculations and the print, and then we return back. Right?
Mhm.
Everybody see that? So let's run this program, all right? Because what? Each time a gas price, a gas total, a tire total, and a cost total will be passed and calculated, all right? So debug. See? Same exact thing, correct? But you see, this time the variables was local to the main, and we had to what? Pass them as arguments to the other function so that it would know the value. Everybody got that? All right? Okay. All right. So that's what they mean by passing value. But like I say, you pass those values, but then you have to make sure. Now, if I said, okay, I wanted to go to my data file and I want to add maybe a name. I'll say Bill, John, Tim, I'm going to tell you. All right, so now, so if I want to read string, int, now, all right, so what happens here is, well, I'll do this. I'll do this. Just to kind of give you an understanding of what's happening. Okay, so what? This would be a string, int, right? Int, and a what? What this would be? Be a float, all right? Right, so now watch. Let's go back to the program. If I gave you what we've just done, gave you the program we've just done, and say, I modified the data file, and I want you to take the what we have in the data file and use it as a reference to modify the program so that it will work, where it'll print out Bill, 10, 40, and 100.28, you know, as the output. What you'd have to do is go back to the program, but look, we know what? We don't have to mess with this because that's just the data file, but we need another variable, right? Well, first, we need to do what? String, right? We have to load that header file, correct? In order to do string, all right? Now, so in here, I'd have to do something like what? String name, okay? I've introduced name. But now, I'm gonna have to introduce what? Something like double, I say double, and I could say that cost, right? And fin total equals 0. Now, but then I'd have to take what? I have to take this off of here because what? This ain't int no more, and this not int, correct? So what I got? String, int, float. Okay, so that's good. But now what? Here, when we read in our data, I'm gonna do an in data what first? I gotta read in what first? What's the first thing I gotta read in? Name, right?
Name.
So I gotta read in the name, read in gas, read in tire, and read in cost, right?
Yes, sir.
Okay, now, this is where it gets more interesting. If I wanted to print out the data that I read in, all of a sudden what I have here, what's my prototype? Int. But what should I be passing? I should be passing what? String, which is the what? The name, right?
Right.
Int and double, correct?
Correct.
All right, but you see how you have to be able to see what's going on, right? So I'm reading in a string, int, double. All right, so now when I go down here, in my call, what my call? Right here, I got a what? I gotta have what? Not an int and double. I gotta have what?
A string.
String,
Which
yeah.
is this is the actual variable, which is name.
Name.
Right. So now what? Name, which is string, gas, which is int, time, which is int, cost, which is double. You understand what I'm saying? And look, 1, 2, 3, 4. 1, 2, 3, 4. But string, int, double, string, int, double. So you understand that the programmer, you know what it is you passing, what it is you're reading in, etc. Correct?
Correct.
All right. So now you're still not finished because now you got to go to the definition and what? I need to do what? Pass what? What I had in my list? I had my list in my call. Name. See, I could have put name at the end. It didn't matter, but I got it at the beginning. Correct? So the first thing I should have here is string, right?
Mhm.
Name. And this name is not the same name that's in the other one. And then what? Cost should be what? Double, right? Because we say we want it to be double, right? So now you say, well, oh, I'm finished. I got the program. But where in here are you printing the, and this could be double. Where in here are you printing the name? You're not, right? So you're going to have to do what? See out. And then I'm going to do the /n/. See out /n/n/t. And then what? Name. And name. Right?
Mhm.
And this should be I'll just leave this as /t. So you see how much needed to be done? And like I said, we got to run it to test it still, but it's close to be, I think it's correct the way it is. All right? Double. Okay, we returning a double, returning total, which is a double. And what? Here we got to say, so we change this to what? Double. You understand? If we returning a double, when we doing our definition, it should be double, right? And then here, when we doing our function call, we want to return it into a double. All right?
Mm-hmm.
Now let's run it. All right? So we go to debug and we run it. And I got an error. Let's see what the error is. Or let's say, return type cannot overload function alone. Let's see, where is this? Double calculate. What I'm overloading? String, double. No. Double calculate. Okay. Okay. All right. Let's see. Calculate. Name, int. Well, string, int, float. String, int, or double. Double. All right. Calculate. And let me see what return. Return total. Total is that. Oh, here. That's in here. Okay. Is that it? I think that's it. Let's see. All right. Okay, yeah. See? So what I didn't do, I told it I was returning a double in the main or in my prototype, but then I had int as defining what my function was. All right. So all that needed to be fixed. So what I did, rewrote the program where it passed what? The name, also rewrote it to where the cost was changed to a float and then calculated. But see what all went into just changing it to add that one thing to it, right? And all that's dealing with functions, passing values, etc. Now, there's one. Well, let's go through the chapter. I don't want to just go ahead. it'll show us. But any questions? Anybody with any questions? I know it's a lot, man. Hey, it's a lot. And because this part, most of this is what you're gonna need in 194. Because then 194, you're gonna be dealing with, and I know when I teach it, we start off with two-dimensional arrays, reading data from a data file. And then we jump into writing programs with functions. Every program you write after that, you write with functions. So you got to know passing the values. You got to know your argument list. You got to know how to list them, whether you're going to use prototypes or whether you're going to list them. You know, off the top, man, you're going to need to know it. Got to know it. So in our program, what we did, when we passed, this say display value 5. That's just like us saying calculate gas. All right, we know gas was equal to the first thing ran in, so which was sent to the function call, which we had calculate right here, and they got display value int and then num. So see, now let me give you another example about what I meant. I just want to show it. What I meant by name in this function is not the same as name in the other one. Gas in this function is not the same variable as gas in the other one. Check this out. In this function, I could say 111. Num111 is different from name 111 is different from name, right? Right? That's a different variable name, correct, class?
Correct.
All right. So I need to get over here. So all I'm doing is adding that 1 to the end, or 3 ones to the end to show you that I'm changing the variable name. Now, notice I changed the variable name. But when I change the variable name, what? Now it doesn't recognize what gas is, correct?
Correct.
Because what? Gas is not being defined. What's being defined? Gas 111. So whatever I call it in this call line here, I have to use it in my function 111. Oh, all of a sudden that one's good. All right, 111. All right, 111. So you see what happens? Now it knows what that is, and then I do name 111. All right. There's still gas is not a part. It got to be gas what? 111. Tires 111. Cost 111. So the values in the main function is associated with name, gas, tire, cost, but in the calculate function, you can give them a whole new name. You understand what I'm saying? Because it's a different scope. Everybody got me? But you could use the same name, but you got to realize that what? It is not the same variable, all right? It's not. All right? It's a new variable because here you're saying string this. You're introducing that variable here. If it was the same one, it's a different scope, all right? But I just want you to understand that. Because you might see a program and say, well, wait a minute. They use gas up here, and down here they use something different, but they got they read the gas and output it. That's because when they introduced it here, they introduced it and declared it as a new name, and now it takes on that value and using that variable. All right, the value of that variable. All right. Okay. Now, so that's what I was saying. It passes that value into that variable. All right. So that's pretty much what we went through right here. All right, that int value, and we had what? String, int, float, all right? In here, they just have one. But notice, the prototype says what? How many variables going to be passed? Values, one value. What's the data type? Int, all right? So when I do my definition, I have to do what? Int, declare int, and then what? Give it a function, a variable name, so that I can output that variable name, the value of that variable in this function. All right, so that's all that's saying. But look what they did. They called display value. They passed 5. Now 5 is a value, right? But they could have said int x equal 5 and pass x. It would pass the 5. Then x equal 10 and then pass 10. We like pass x, which x is 10. Then x equal 2, then pass x again. X equals 16 and pass 16. All right. So you can pass a concrete number or constant, or you can pass an actual variable. All right? That's all that's showing. All right. Now, Mr. Top, all right. function. Okay, 3 parameters. We did 4. We did 3, and then we did what? 4. So if you're gonna do 3, this tell us we're gonna have what? 1, 2, 3 ints being passed. Where the function, where the variable, where's the function is being called? Okay, show sum is where it's being called. I'm looking at value 1, value 2, value 3. Looking at this and looking at this, I know that value 1, 2, and 3 should be what? Integer. All right. And then what? Value 1, 2, and 3 are the variables defined in the main function or declared in the main, but they pass in what? Value 1 to what? Num1. Value 2 to num2. And value 3 to num3. So you see how you can send it to a different variable, but the value gonna be stored in that variable, whatever that list is. All right, whatever that list is. All right, and it's just showing you value 1's going into num1, value 2 going into num2, value 3 is going into num3. All right, so it just created a new variable, and the value of the previous variables are going into those the way they listed. If I had num3, num1, num2, then value 1 would have been into num3, and value 2 would have went into num1, and value 3 would have went into num2, because that's the list that we have. So whatever order this is, you have to make sure this is the order that you want it, because that's how it's going to be passed down. No matter how you say, well, the variables, this okay. No, whatever the order of this, that's how it's going to place them. All right. So sometimes that's why you have to have your data types correct and all that. Now, all right. So this, and that's it, passing by the value, which we did. We passed change me none. We did what? Gas, tires, and cost, and then we added name. So all they're telling you, you can pass it using that variable, no problem. All right, which we looked at. And whatever value is in that variable, it'll just send it to that new variable, and it'll allow you to print. All right. Now, all this saying is a lot of times you can create what? Program using menus, and what? You can actually have that menu in a function where you keep calling it rather than having to what? Keep writing and writing and writing. So what they did here, show menu, every time they executed, where is it? And before they did all this, right here, they'll do where's show menu? Show menu should be somewhere. Where is it? Show menu. Because that's the choices. Where's show menu? Show menu. It should be somewhere here. Yeah, see show menu. So every time they execute that do, so that they can make a choice from the menu, they'll do a show menu, and then all this information is gonna be the calculations and whatever with the case state. All right. So that way, you always have it, just reference it, bam, and put it there. All right. So you don't have to have it in the do and then keep going through the do. Hey, have it outside, and your code is not too messy. All right. Mm-hmm. All right. Now, return. We looked at the return, but when you return a value, you're returning it back to the main function, and that scratch that, the calling function, and you can assign it to a variable, right? In hours, in a sense. So let's look at this. When you return a value, this is void though. This is not returning anything, all right? So I don't know why they say return here. All right. Oh, the return statement. Oh, all right. Return 0 mean what? I'm at the end of the main. If I have this program here and I have this if statement in here, when you see that return, it kicks you out of that function. You don't have return. You can't say return a number because what? Or integer or float or whatever, because what? You said void. But just return kicks you out, meaning it's not going to print this down here. If this is this, sorry, whatever, kick on out and go back to that next statement in that calling function. All right. So that's what'll happen. It won't even execute this. All right. So that's what that return does. Now, return on a value from a function. We did that. all right? Returning that value from a function, remember what we did? The function here is called sum. Our function was called calculate. So what happened, what we did, we had to tell it what data type we was going to return. Remember I told you a bool, int, float, char, string, whatever data type, you have to give it that data type. You have to tell it in the prototype. You have to tell it in the function definition. When you call a function, what you do is you set it equal to something, all right? So here, this would be the function definition, int, because what? The prototype says what? Int sum. Is this the prototype? No, this is the function. This is the function header. Int sum. So this means in this function, we returning an integer. Sum, int num, whatever value is being passed for num, and whatever num1, and whatever value is being passed for num2. Say it's passed a 3 and a 4. So 3 plus 4 is going to give you 7. This says return num1 plus num2. So it's going to return 7 back to that calling function. Now, you could have said x, int x is equal to num1 plus num2, and then return x. And just one more extra statement, one more extra declaration, but you could do it that way also. But they just did it all in one. Return num1 plus num2, and it's going to be sent back and assigned. Just like here, we had, I don't know why this thing is not doing my bottom. Oh, I know. I think I know why. Why my bottom two above? All right. So what happens is, see here we did double, calculate, string, name one, int, gas, whatever one. But anyway, in here we said double total, all right? Total is equal to the gas plus tires plus whatever. But then we did what? Return total. Now, I could have just did return this plus this plus this, but then I wouldn't been there. I'd have to say print out or see out this plus this plus this. So I'm writing my statement twice, but I wrote it one time, set it equal to total. I'm printing total here, and I'm passing total. All right. So I mean returning total. So I'm returning total as a what? A double. So when I go back in my program, the main program, which is with the calling function, double tote. So now I'm introducing or declaring another variable called tote. Whatever's being returned from this function, all right, and I'm passing these values at that time, whatever value is being returned, going to be returned back into tote as a double, right? And then I'm adding it to fin tote. Okay, so that's the same thing we did already, all right? So you are returning a value. And remember I told you can only return one value, all right? Now, calling a value returning function. All right, but I'm saying we did that, all right? So we did the call. Where is it? Where you said it, oh no, that's the function. Where is the call? See? Total is equal to, see here? So we set total to be of int, but then what? This is our function that we calling, but we returning num1 and num2, but num1 and num2 is being passed back to this function, and it's going to be set equal to, well, total going to be set equal to what that value is. So that's just like saying, whatever this function is returning, all right, based on the values given, total going to equal to that return value. And then you could print total here, all right? So that's basically how the program we wrote was written, all right? Now, all right, so this should be basically the same thing, another example, all right, given, all right? Now, see what they say, area is equal pi times square radius, see, so where's square? I think square radius. Okay, square. See, square. So this is a function, all right? And the function returning a double. So whatever this function returned, they're multiplying it by pi, and then whatever that return value is multiplied by pi is going to be assigned to area. So it's the same thing, but it's just more of an expression, all right, added to it, all right? So let's see, saying they're telling you the same thing. The value being sent is being multiplied, but then once it's squared, now the squared is being multiplied times this to be stored into that value, which is going to be the return, all right? Now, returning a bool value, you can return that too. Remember, bool is yes, no, true, false, on, off, same difference. You can return that too. Return status. Start status could be true or false. It's bool, which is what? 1 or 0. So you can return that value too, and then ask the question if it's true, do whatever. If it's false, do whatever. All right? You know, because you can write code in that fashion where you're checking on an off value. Local and global variables. And like I say, we talk. Global variables can be used anywhere in the program. When you make changes to them, they change, no problem. Local variables, on the other hand, can only be used within that scope. So you would have to pass those values to that function in order to use them, all right? Now, we're going to get to a point where we can pass values by reference. When you pass a variable by its value, the variable does not change. The value of that variable will not change. Now you say, well, Mr. Vessel, what do you mean? Okay, it's almost like how would I say? If I pass something on to you, a test score. So if I pass you a test score or a test, and I'm just passing it by the value, whatever's on that test paper, that's what it is. If I pass by reference, I could pass you that test score. You'd have a test score on it, but if I go back and say, oh, well, something changed, I modified it. When I modify it, whatever you have should be changed, all right? But if I say pass by value, whatever that value is at that time, that's it. It ain't gonna be changed because you're not in that scope or whatever. And I'll show you that right now in a little while. So global variables and local variables are totally different. And like I say, you got to be careful. So now, so it's just talking about the global and local, which we talked about, where once a variable is local, you have to pass the value in order to use it, okay? You cannot use that value. Now, you can create the same variable name by passing, like we had gas, tires, and cost. You can use the same variable names when you pass it, but it's in a different scope, all right? Now, so the thing is, let's go back to the program. And what I'm gonna do, I'm gonna erase all this out, and I'll create a little small program, all right? I'll just create a little small program. And I'll take this while out. Take all that out. All right, take this out of here. Yeah. All right, so now, oh yeah, total. I don't want to return. Oh, that's what I'm going to change that. All right, so we have just a basic program. Take this double off. I'll say void. Take all this stuff here off. I'll just pass one value and I'll show you. I'll do an int. All right, int num. All right. All right. Num. And it doesn't know what num is because what? We don't have it set up yet. All right, so let's go back up here in the program where we have, we could say int. I could take that out. Take that out. I can take this out. I don't need that footer. I don't need this. We done did the input file. All right, so now I'll do int gas and I'll say equals 3. Gas equals 3. All right, now I'll say 33. Now, and tires, it's tires, I'll just say total. All right. So I'll do something like this. Total is equal to total plus gas. All right. Now, in our call function, let's call a void calculate. And I'll say gas, right? Okay. I'm passing gas. Oh, that sounds kind of funny, but I'm passing the variable gas. Now, if I need to say here, void, and I'll just do an int. Int. All right, so we're doing an int. This should be what calc void calc gas. Okay, calculate. Let's go down to the bottom. Void, what's going on here? Void calculate. That should be right. What's the area? Void incomplete type is not allowed. We'll see what that is. I think that's right though. You got your prototype, void calculate int. Okay. Oh, that's right. They telling the truth. All right, calculate. Now, so what happened is, what I'm gonna do, I'll call it gas. Now, down here, what I'll do, I'll say gas is equal to times 2. All right. So now, so gas is 33, right? I'm passing gas to calculate. So 33 will be passed. Then I'm gonna double it, right? And so now I'm gonna do C out. All right. All right. So now, so then when we return, what I want to do is I'm going to print gas, all right? Now, so looking at this, you say, okay, well, Mrs. Sylvester, why would you do that? What's the difference? All we're doing is printing out gas multiple times, right? That's what it looks like, correct?
Correct.
But in actuality, int gas, right? So gas will be passed here. Well, I got total equal total plus, oh yeah. Right, well, that don't matter because I could take this out because I didn't do anything with it. All right, so here we go. It's 33. So I'm gonna call calculate using gas, and now gas will be passed, which would be 33. So 33 times 33 is what? 66, and it should print what? 66, correct? Then it's gonna return back to the main. And it's going to print out the gas value in the main, which should be
66.
Watch. Nope. Remember I told you there were 2 different variables?
Oh, right.
You understand? So whatever I did in the main function, I mean in the call function, didn't have any effect on that variable. All I did was pass that value. It didn't reference the name of the gas or nothing. It just said, okay, take 33, send 33 on, and where it's going in a new variable. Remember we said that. Remember we said every time we have that function list and we do int whatever, that's a new variable, correct? Okay. Even though it's the same name, right? So we doubled it. and it printed 66. Then when they returned back to the main and printed gas, it printed what? The original value, which is what? 33, because it was never changed, right? It was local to that main function, right? Now, if you wanted to say, well, Mr. Vesta, how can I manipulate that value without returning it so that when I use it, it'll automatically change the value, okay? You do that by passing it by reference, right? And that's simply by using the ampersand sign, all right? So what happened here, you would do something like this, int ampersand. That means I'm gonna pass an integer value, but I'm gonna pass it by its address reference.
Okay.
Right. So rather than saying, okay, you passing 33, I'm passing the address where 33 is located. So when I use that value in that address, I'm at that address, and whatever changes I make, gonna change the value at that what? At that address, all right? So that's when you use the reference, and that's if you want the value to change. So now when I do that, if I do it there, now I'm gonna have to also do it here. You understand?
Yes, sir.
Now when I do it like, is that right? That is, yeah, all right? So when I do it like this, what should my results be? What should my results be? Just a guess.
You'd be like 33 and
No, I remember the first one was 66 because that was the double. Remember we doubled it and we printed that. But then when we turn back to the main, what is going to print?
the main's not gonna print 33.
No, it's going to print 66 because we're doing the reference. Remember? Watch. See what I'm saying? 66. When we pass by that reference, we saying, don't worry about what the value is. Go to that address and grab that value. Make the changes. If there's any changes, make the changes and put it back in that address. You got me?
Yes, sir.
So what happens is I pass the variable called gas. At this point, it's 33, correct?
Correct.
It's passed into this function, but it's passed by what? By reference, correct?
Correct.
Meaning I'm working with and see, that's low-level programming. Now I'm working with the address, not the value, the address. So now, anything I do to gas at this point, anything will be automatically done to the what? At the address. You got what I'm saying? If I set it equal to 0 here, it's going to be set to 0 in the main, anywhere I have it. You got me? Because I'm changing it at the address. I'm not referencing just the value. I'm referencing the address.
Okay.
You got me? Yeah.
Sure.
So, like I say, whatever's done here, I could say gas plus 2. You know, whatever I want to put. You know, it's going to change gas to 35 here. When it returns back, gas will be 35 because it's going to be that referencing that address and they're going to make the change. So when I run it, both of them should be 35. Because all I did was change the, did it run? Yeah. All I did was change the expression. Okay? So that way you could say, okay, I want to use that variable and I want to do some manipulations in that function, but I'm returning something else already, and I don't want to have to return this to do whatever. I'm gonna just pass it by reference, and it automatically changes. All right. Okay. All right. Now, global constants. We know something. Well, something is a constant, you can't change it, right? You cannot change it. But it's global. You can use it anywhere, but it cannot be changed. All right. All right. What else? Static variables. All right. Now, static normally means that there's something that is given a particular value and cannot change. If a function is called more than once in a program, the value stored in the function's local variables do not persist between function calls. All right. This is because the local variables are destroyed when the function terminates. And remember, that was like, well, I took it off. Remember, we had int total, and I told you every time the program calls that function until the end of file, it won't give you an error on int total, because every time you leave that function and you return back, it's starting over anew. All right, so that's what it's saying. So you won't get that error. You know, it just starts over anew. All right, because once you leave the function and come back, oh, you're starting over anew. All right, it doesn't hold anything. All right. All right. Now, wait a minute. Arguments. Well, we talked about arguments. All right, and them arguments would be, well, when we had what it was. Well, calculate gas, comma, tires, comma, cost. That was our argument. That was in our list. All right. So look here. Void show area double equals 20.0 double equal 10.0. So these are arguments. You see, these are arguments. All right. Yeah. So and then there's double length equal whatever, double width equal whatever. All right. I normally don't give program where you're actually defining a value to a variable in the argument list. Normally I do it where you actually receiving either inputting it from the keyboard or you're sending it to a function. But these are some ways you can do it also. Now doing stuff this way, you can do that, but this is more or less, you know, like they say that static way. And every time you execute this function, 12 is being sent because it's a constant. 12 is 12. You know, you can't change that. But if you had X, then X can change, and every time you call that function, whatever X is, you're doing whatever. But I'm saying you can do it that way also. All right. All right. And it's showing you also some stuff. Let's see. This is the reference we talked about. Remember I told you passing by reference. All right. Look. When I look at this, void, double num, int, ampersand, ref, var. Whatever variable is being sent to this reference variable here, it's when you do whatever times 2, it's gonna change that variable, the value at that address of that variable. All right. So let's see if we can find it. Okay. Here is the prototype. Remember we had int ampersand? So that's where your function prototype. Void double int amp, still that's your prototype. So in it, well, yeah, that's all this is. Was that? Somebody had a question?
Oh no.
Okay. All right. So like I said, it's the same thing. This and this. Exact same thing. Now, if you look at the program, look up here. It got int. This is the prototype. Int ampersand. So what? That means when we do our function call, the value that we call, let's look at it where it is. Here, double num value. Value is equal to what? 4. Correct? Now, so we're going to pass value into a variable, reference variable called what? Ref var, right?
Right.
Whatever we do to ref var will be done to what?
Int value.
Right. So if I double ref var, I'm actually doubling what? Value. You
Right.
understand? Right. So that's all I'm saying. We did that example. So what they did here, they just did the ref var and they didn't print. They could have printed it here. They'd have got 8, and then they came back, they printed it here, and they printed value, and they got 8. You understand? So it's the same example that I gave, but I printed them both to show you without the reference, it won't change the value of value. But with the ampersand, the reference, it does make the change for that variable value. All right. So that's what they're saying, passing by reference. Now, you might say, well, what if I had more than one thing to pass? Remember, we had the last time we passed 4 different things. We passed the what? String. If it's a reference, you do ampersand. If int, ampersand. Another int, ampersand. And then we had double and ampersand. So that's all you do. It ain't no big deal. All you do is, oh, this spelled wrong. All you do for each one that you want to pass by reference, because you don't have to pass them all by reference, but you can choose which ones you want to be changed or whatever. That means whatever you're doing with the string, if you want to print the word backwards, when you send it to that function and you manipulate it, if you pass it by reference, whatever you do to it, it will be done to that variable. If I had an int value, I doubled it. Whatever's done, it'll be done when I return back to that call function. If I was doing this one and I was on the square root, whatever's done, it'll do it here. And double, if I was dividing by whatever to get whatever's done, it'll be done for that variable. All right. So that's how it works. You know, you just using the ampersand. All right, just using the ampersand. All right, and that's passing it by the reference. All right. So, and if you look in here, this one got void double num, and then int ampersand. Then void get num, int ampersand. So in the get function, they pass in an integer. All right. So whatever's being typed in is being passed by reference, and then what? Whatever they type in, it'll be stored in that in num user or user num, but it's also being changed in what? Value. So when you return back to that function, value will have that what? Whatever that user typed in. So you see what happens when you pass it by reference? You ain't got to try to return a value back. You can use the reference, and the reference actually change it when you add that address when you type it in or do whatever. All right. So that's how the by reference works. All right. And see, look, that's what I was telling you. If you had more than one to actually pass by reference, just the data type, ampersand, comma, data type, ampersand, comma, data type, ampersand. And then in your function definition, data type, ampersand variable, data type, ampersand variable, data type, ampersand variable, data type, ampersand variable. But then once you do that, all you do is just do your work, because what? I'm going to use sum, num1, num2, num3. That's my variable, so I could use those with no errors. But whatever's done to num1, num2, num3, and sum is really being done to whatever those variables are in that calling function. You got me?
Mm-hmm.
It's being changed in that calling function. All right. Yeah, so that's what be happening. Yeah. Oh, yeah. Now, they got something called overloading. What it is, you're using the same function definition, but you might be look, like this one, you're using the same function, but then you're passing an int here and returning an int, and you're passing a double and returning a double. But that's called overloading. All right. It's like I define this function, but I'm using it multiple times. All right. So it's overloading. But it's like, you can do that though. You can do that in C++. Rather than what? Oh, well, I need to return a double. I need to create a function. Or I need to return an int. I need to create another function. If the calculations and everything is basically the same, you really don't have to do much. Or something in it that you're doing, you don't really have to rewrite it. Just use that same function. Right?
Mm-hmm.
All right. And like I say, that's overload. I don't normally give programs with overload or nothing like that. And now they got it with character. Same thing with character. This is what, if you look at this, just looking at this part of this program, you got void get choice. Get choice is the function name. Char ampersand letter. Now looking at this, letter has the data type of char, but whatever I do to letter is going to be automatically done to what? The variable in that calling function.
Okay.
Yeah, right. Whether I take a lowercase letter and make it uppercase or whatever I do to it here, it's gonna be automatically done in that calling function. So that's how you kind of look at that stuff. The exit takes you out. Exit function causes a program to terminate. Okay, regardless of which function or control mechanism you execute. So if you have exit, open parentheses, close parentheses, bam, you out of that program. All right, you out of it. All right. Yeah. So like say here, how they got this function. Once they do this, the program terminates with the exit by and then exit 0. So that means what? You could put it anywhere in your program, no matter where. Once it executes that, boom, you out the program. All right. Then they got something called continue. Continue allows you to skip some stuff. All right. Then let's say stubs and drivers. All right. And the drivers pretty much, they talking about menu-driven systems and stuff like that, which we kind of looked at already, where you can have your system that executed multiple times. You have that have those codes written. You just call that code over and over whenever you need it. Kind of like error messages. What you can do, you can have X number of functions set up, say an error message saying number is not if you had a function where you had to input a number between whatever and whatever, and you can have it call a function that's an error message function. You can call that error message function, pop back, then execute your menu again. Then you can have multiple error messages. And that's how they do it with like with Windows and all these other applications. They just have a whole list of error messages, and based on the code and when you get that error message, they'll just execute that error message. It pops up, and then you see it, try to resolve it, and continue. All right. So, and that's basically the chapter. All right. But any questions? Anybody with any questions? I'm gonna try to open up those tests also. All right. Well, not try. I will open those tests. All right. And I'm gonna open up chapter 6 quiz. I need to open that up. All right. So anybody with any questions? Questions?
No, sir.
All right. So I'll see y'all next week. Like I say, next week if y'all want, we can have class and we'll do a review on whatever. Or y'all can just take the time to work on your stuff. Because we done covered the chapters 1 through 6 and whatnot. But I could kind of like show y'all arrays and how arrays work, which is kind of like a little bit of chapter 7, but not hold you accountable to it, but kind of give you a little insight of the start of 194 or whatever, if y'all want.
That's fine.
Okay, all right, we'll do that. Now, we could do that at 10 o'clock because I don't have no more workshops, man. So if y'all want, do it at 10 o'clock. That's good?
Yeah, that works.
Okay, all right. So we'll go back. I'll send an email to everybody, letting them know we'll kind of go over some stuff in 7, but won't be held accountable, just for FYI. Just FYI.
Okay,
all right.
cool.
All right, then, man. Y'all have a good one. Do my test, and I'm going to open up those other tests, too.
All right, yes, sir. Thank you. Appreciate it.
All right, have a good one.
You too.
All right.